Everyone, today I am going to introduce you to spacecraft or satellite and launcher. As an introduction, I would like to raise a question. Why we go to space at the first place? So first, for the global perspective, the higher you are, the more of Earth's surface you can see. So we can utilize this for urban planning, agriculture, fishing, vessel monitoring, disaster monitoring, and others. Second, for clear view of the heaven, telescope that mounted on the satellite on orbit have clear view. This will help astronomers to observe the sky without interruption from clouds and ionosphere. Third, the free-fall environment, enabling us to develop advanced material that is impossible to make on Earth. Gravity tends to pull heavier metal to bottom and making a uniform mixture difficult to mix. 4. For an abundant resources. As example, solar energy and extraterrestrial materials. You may find out that iron and water are brought to the Earth by the meteoroid. And fifth, to improve human life. As example, GPS technology eliminates maps and help in tracking, navigation, and surveillance in deeper and detailed location. This makes your life easier, especially when you are traveling or trying to locate something. Miniaturization of camera and sensor for multi-purpose. As example, handphone with camera and CCTV for surveillance. And life support system technology for astronauts used to help in medical and safety, such as fireproof and thermal blanket, health monitoring system, and others. Okay, there are 4 types of space activity. For the civil, most common utilization of the satellite is remote sensing. So remote sensing satellite locate in the high altitude, enable the sensors and camera to see broad area and report very fine details about the weather, the terrain, and the environment. The sensor receive electromagnetic emission in various spectral bands that show what objects are visible, such as cloud, hill, lakes, lightning, typhoon, and others. This instrument also can detect objects' temperature and compositions, wind direction and speed, and environmental conditions such as erosion, fires, and pollution. This will help to improve agriculture, urban planning, natural disaster monitoring, and so on. Some countries use remote sensing satellite as their spy satellite to monitor troop movement and violation of international treaties, such as international border violation and human trafficking. For the commercial types, the most common is the communication satellite. While two people are too far to see each other, they can see the same satellite in high orbit, meaning that they can relay the message from one point to another point. The idea of using satellite broadens the horizon for communication. So you will find the satellite television in your home, satellite telephone for relief workers and military, and also satellite telephone services in remote area and isolate island. Then another use of space is for the science activity. So the scientists use satellite to help research about the nature of Earth, the solar system, and the universe, as well as to collect data about Earth and a space environment for scientific study. This is actually to improve human life, to find a solution how to better climate change and global warming, as well as to test new technology for spacecraft. Uh, Others activity that use space is for the national security. So normally military and defense will use satellite for the surveillance uh, and navigation and tracking. The space program is divided into two segments, space segment and ground segment. Space segment is the spacecraft, and ground segment consists of ground station, command and control center, data storage, analysis, and distribution. The ground segment can be in one place or in different building or placed in different country. The space mission architecture is a space mission requires a variety of interrelated elements called mission architecture. Central of the architecture is the space mission. The whole system is called mission management and operation. At the heart of the space mission architecture is the mission. Simply stated, the mission is the reason why we are going to space. All space missions begin with a need, such as the need to communicate between different parts of the world or to monitor pollution in the upper atmosphere. Understanding this need is central to understanding the entire space mission architecture. Mission statement tell us three things. First, the objective, why we do the mission. Second, the mission users or customer who will benefit from this space program. Third, the mission operation concept, how the mission elements will work together to ensure this program is successful. As a space segment, it consists of the spacecraft defined as the vehicle designed to operate with or without a crew in a controlled flight pattern above Earth's lower atmosphere. Spacecraft example is a satellite, lunar rover, space shuttle, uh, and probe. While satellite is defined as any natural or artificial body moving around a celestial body such as planets and stars, artificial satellite is a human-made craft or vehicle in space orbit. We classified the satellite into seven class, which are pico, nano, micro, mini, small, medium, and large. And payload defined as the load carried by a vehicle exclusive of what is necessary for its operation, especially the load carried by an aircraft or spacecraft consisting of things necessary to the purpose of the flight. And spacecraft bus defined as the system and structure within the satellite provide functions to allow the payload to perform its intended mission. This include providing power, thermal protection, stability, and orbital control so the payload perform within its design limits. So the spacecraft bus exists solely to support the payload with all the necessary housekeeping to keep it healthy and safe. To visualize the relationship between payload and bus, we can use school bus as analogy. The body and frame of school bus represent satellite structures and mechanism, radio and driver as communication system, steering as a vehicle control, battery and alternator as electrical power, aircon and heater as life support system or thermal system, engine as the propulsion system, and passenger as a payload. Without passengers, bus have no other purpose. So as satellite, without payload, satellite have no mission and no objective. It will become useless. So spacecraft bus have seven subsystems, which are attitude determination and control, or we'll call it ADC. Then communication, which is TTC or telemetry tracking and command. Onboard data handling or OBDH. The power subsystem, thermal subsystem, structures and mechanism, and propulsion. So this figure show the typical spacecraft bus consists of antenna as the communication system, imager as the payload, star tracker for the altitude determination and control, solar array panel for the power, and thruster as the propulsion system. So as you can imagine, designing, building and launching space mission requires a number of large and expensive facilities. Communicating with and controlling fleets of spacecraft once they are in orbit requires even more expensive facilities. The mission operation system include the ground and space-based infrastructure needed to coordinate all other elements of the space mission architecture. Operation system include manufacturing and testing facilities to build the spacecraft, launch facilities to prepare the launch vehicle and get it safely off the ground. The communication network and operation center used by a flight control team to coordinate activities once it is in space. This team function is same with air traffic controller for aircraft. You will learn in details about communication system between ground control and satellite in the topic satellite communication soon. And the ground segment consists of all the ground-based elements of a spacecraft system used by operator and support personnel, as opposed to the space segment and user segment. The ground segment enables management of a spacecraft and distribution of payload data and telemetry among interested parties on the ground. The primary elements of a ground segment are a ground station, which provides radio interface with spacecraft, mission control or operation center, from which spacecraft are managed, the ground network, which connect the other ground element to one another. Also, some satellites have remote terminal used by support personnel and spacecraft integration and test facilities. And last is launch facilities. These elements are present in nearly all space missions, whether commercial, military, or scientific. They may be located together or separated geographically, and they may be operated by different parties. Some elements may support multiple spacecraft simultaneously. In mission operation and control center, mission manager lead the program from the beginning. The mission management team must define the mission statement and lay out workable mission architecture to make it happen. Team members involved in every element of mission, including designing, building, and testing the spacecraft, performing complex analysis to determine the necessary mission orbit, identifying a launch vehicle and launching the spacecraft to its mission orbit, and bringing together the component of the mission operation system to allow the flight control team to run the entire system. And the mission operation team monitors the spacecraft health and status to ensure it operates properly. The flight control team or satellite operator usually operate from a mission control center, such as the one in the pictures.